I have a fairly straightforward agenda. I want to start off talking about a general introduction to the problem, and then I want to get into some very precise definitions which will allow us to focus in on a solution to the requirements problem. I am going to discuss at some length the whole concept of business rule invariance across modernization, and hopefully I'll be able to make that concept pretty clear. Then I want to get into the nitty-gritty of business rule extraction from legacy artifacts, and then we'll close off with a summary and open up for questions. With the introduction, I absolutely love this quote from Fred Brooks, the author of The Mythical Man Month. In a 1987 essay, he said, "The hardest part of the software task is arriving at a complete and consistent specification. And much of the essence of building a program is, in fact, the debugging of the specification." How do you see the problems that result from requirements gathering failures? See it until you actually go into production. You will go through the whole process. You will develop your system according to the requirements. But when you put it into production, you're going to find errors that never occurred in your testing. This was the genesis of the Federal Reserve project, which I'll be talking about in just a second. But this leads to the one of the fundamental points I want to discuss today. We got the existing testing methodologies that we use, which are almost entirely requirements-based testing, are fundamentally flawed when applied to application modernization. When you test against flawed requirements, you can pass the tests, but still be wrong. Talk a little bit about what we learned out of the Federal Reserve project. This was classic legacy modernization coming off of an IBM mainframe, 2.3 million lines of IMS COBOL being rewritten into Java and Oracle. This was a pure technology refresh with like-for-like functionality. It was a rewrite. This was not a code translation. There were just an astonishing set of resources available to the people working on the project. We had one whole group of people who sat and read the code and updated the documentation. We had a completely separate group of business analysts who started from the top and worked their way all the way through the requirements, the processes, a classic business analysis approach. We also had an automated business rule extraction that had been done from the legacy source codes. And finally, we had the group that I was part of, which was the comparative testing group. And I'll come back to that in some detail as we go further along. But in general, our team's goal was to achieve a set of tests that provided a 100% coverage of the legacy code. In other words, we're not doing code coverage of the new Java code, although, of course, we were doing that as well. But we were creating the tests against the legacy code. In the process, we would be finding and correcting errors and omissions in the specifications. This is the dynamic business rule extraction we'll talk about in a minute. But unusually, our group was not allowed to actually create the test cases. We had to write them up the same way that you would write up requirements going into building a system. And then we had to take those requirements to the testing group who would create the actual test. And here's the most interesting part. To create the tests we specified, they used the same information that was used to build the system from those other three sources. The interesting part here was they got it right about 50% of the time. Bottom line is, even with the best analytical information, your specs will still be wrong or incomplete somewhere on the order of 30 to 50%. These comments mostly apply to large or very large systems. By very large, I mean more than 10 million lines of COBOL, very roughly speaking, or 5 million lines of Java. Our large projects, 1 to 10 million lines of COBOL, are the equivalent. It will sometimes apply to smaller projects, but the content of the presentation today focuses on these large to very large projects. The requirements problem involves some truths that many people find uncomfortable. Technically, successful projects can in fact fail, or far more likely, overrun their budgets as a direct result of insufficient or defective specifications. Specs to the users, and they can review and sign off on the delivered system. But at the end of the day, does it really do what it was supposed to do? To your tests, absolutely. It passed all the tests. By the business, well, one of the problems here is that the business may not be able to recognize all of the errors. It's simply too complex. They'll certainly see very many of them where they do have results that come out of the new system that are not what they got from the legacy system. But in many cases, the errors are so complex and so deep in the relationships of the data that it's simply not evident. So you go into production with a flawed system. But at the end of the day, the problem is not that we're building the new system incorrectly. We are building it and testing it against flawed plans. And this, I submit, is the source of the functional errors and the shortfalls in application modernization, and also the cost overruns and late deliveries, and of the occasional project failure. Although truth is that we may see lurid headlines relating to very expensive project failures, but by and large, those are relatively rare. What is endemic is cost overruns, late deliveries, and functionality shortfalls. Problem in legacy modernization. Requirements are incomplete, and in some cases, they're just plain wrong. We're going to present a practical solution to this problem. Waterfall methodologies are based on deriving the requirements, building the system, and testing the system against the requirements. Fundamental flaw in both methodologies. People can't tell you what they don't know. No one, original programmers, know everything in these old systems. Or, if truth be told, they don't know everything in the new systems either. The complexity is just too high. Now, we're having a problem getting the slides to advance here.